students, in this video we will do exercise first V and question number first, question number second and question number fourth. Question number third we will do in our next video. The first question is, without actual division, find which of the following rationals are terminating decimals. First is 13 upon 80. So we are taking first part. First part is 13 upon 80. What we have learned for terminating decimals, that prime factors of q, this is in the form of p upon q. So if this fraction will be, or we can say this rational number will be terminating decimal when the prime factor of q will be in the form of 2 and 5 only, not other than 2 and 5. So suppose this is in the form of p upon q, where q is equal to 80. Do prime factors of 80. 2 4s are 8, 0, 2 2s are 4, 0, 2 1s are 2, 0, 2 5s are 10 and 5 1s are 5. So prime factors of 80. Write down prime factors of 80 is equal to 2 to the power of 4, 1 2 3 4 into 5. Now you can write it. 80 has no prime factors other than 2 and 5. So 13 upon 80 is a terminating decimal. Terminating decimal. Okay. For other parts, you will do the prime factors of q and find out whether the rational number is terminating or non-terminating repeating. Now second part is 7 upon 24. Second part 7 upon 24. Third part is 5 upon 12. 5 upon 12. Fourth part is 8 upon 35. Part fifth 16 upon 125. 16 upon 125. Now I am not doing like this. You will do in this way, and I am showing only prime factors of denominator. The prime factors of 24 will be, do it here, 2 2s are 4, 2s are 8, 3s are 24. Or you can do the prime factors of 24 by steps. I am doing like this. So this becomes 2 cube into 3. Now for this, prime factors of this denominator, 12, 2 2s are 4, 4 3s are 12. And do the prime factors of 35. This is not divided by 2, so it becomes 5 into 7. Now 125, 5 into 5, 5 5s are 25, 25 5s are 125. So what have you conclude here? Here in this part, second, third and fourth part have the prime factors other than 2 and 5. Here 3 is extra. Instead of 2, 2 is here, but 3 is the prime factor is not consider for terminating decimal. Here also 3, here 5, but 7 is not considering for terminating decimal, and this is only the prime factor of 5, so this will come for terminating decimal. So are two parts, only part 1 which have prime factors 2 and 5, part 2 will not terminating decimal, part 3 also not terminating decimal, part 4 is not terminating decimal, part 5 is terminating decimal. So you will do all these 4 like the part 1 have been done. Okay, so I am writing here only not terminating, not terminating, this is also not terminating, this and this. Okay, these 3 are not terminating, but this is terminating decimal. I think you understood how to find terminating decimals. This is the question first, and all the parts I have done here. These are not in the form of 2 to the power of m and 5 to the power of n. Now question number 2. What is the question number 2? Convert each of the following into a decimal. The first part is 5/8, second is 9/16, third part is 7/25, fourth 11/24, and fifth 2 whole 5/12. So we will solve it just now. The part 1. Part 1 is 5/8. 5/8. We have to convert this rational number into decimal form. So divide 5 by 8. Now put 0.86 are 48. Remainder is 2, 0, 8 to the 16, 4 remainder, put a 0, 8 5 the 40. Now this comes to end, so this is terminating decimal and it will 0.625. This is in the decimal form. Second part, 9/16. Divide 9 by 16. 9. Not divide, so write down point. 0. 16 5s are 80. Remainder is 10. Point is here, so write down 0. Now 16 6 are 96. 4 is remainder, put a 0. 16 2s are 32. 8 is remainder, put a 0. 16 5s are 80. this comes to an end. So this becomes in decimal form 0.5625. So this time you will divide numerator by denominator in long division and write in decimal form. Now third part, 7/25 you will do in another method. By using another method, make the denominator 100, so multiply numerator and denominator by 4. So this becomes 7 4s are 28 and 25 4s are 100. Now write in decimal form because 20 is here, so decimal put before two places in the numerator. So this becomes 0.28. This is in the decimal form. No need to divide by long division. Now fourth is 11/24. 11/24. Do yourself. I am doing now. Students, I think you also calculated the decimal form of 11/24. Now I am showing how I did it. 24 will not divide 11, so take a point and put the 0. 24 4s are 96. Now remainder is 14. Put a 0. 24 divide 140 by 5 and this becomes 120. Now find remainder. This is 20. Put a 0. 24 8s are 192. Now remainder will 8. Point is here, so put a 0. 25 3s are 72. Now subtract. You will get 8 remainder. This 8 is here and put a 0. 24 again divided by 3. 24 3s are 72. Now again we get the remainder 8. Put a 0 and you are watching that every time we are getting remainder 8 and we will put 0 and 24 divided by 3. So 3 is continued. So you will write it like this, 0.458333 and it is continued, and you will put bar on repeating digit which is 3. So this will 0.4583 bar on the 3. Okay. This is the last part of question number 2nd. Part 5th. 2 whole 5/12. I have shown it here. Do yourself. This division is 12 to 29. You will get repeated digit is 6. So you can write it like this, 2.416 bar. Now next the question number 4. Question number 4 is true and false. True or false. We will discuss here. Now these are all parts. True, false. I will give reason why the given statement is true and why it is wrong. So see all the parts. Now first part is every natural number is a whole number. First part is every natural numbers. Natural numbers and numbers are 1, 2, 3 and so on up to infinite. So here every natural number is a whole number and whole numbers are starting from 0, 1, 2, 3. So you are watching this, all the natural numbers comes in whole numbers, and so we can say every natural numbers are whole numbers. So this is true. The first part is true. Second part second is every whole number is a natural number. Every whole number is a natural number, but 0 in whole number is not a natural number. 0 is not a natural number. So this statement is false, because here the statement said every whole number is a natural number. 0 is not a natural number, so this second part will be false. Now come to the part 3. Every integer is a rational number. Integers, negative integers, positive integers, and 0, 1, 2, etc. And here write down negative integers, -1, -2. You can write all the integers in the form of p upon q. Put 1 as a denominator, and you are watching that all the integers we can write in the form of p upon q. So every integer is a rational number. So this is true. Now come to the part 4th. Every rational number is a whole number. Every rational number. So this is wrong, because if you write 7 upon 13, so this is a fraction, or this is a rational number. This is not a whole number. This is not a whole number. So our statement is false. Now come to the part 5th. Every terminating decimal is a rational number. We have done division in this section, so you are watching that terminating decimals are rational numbers. So this will true. See the examples in the given session. Now part 6. Every repeating decimal is a rational number. So repeating decimals, suppose we are taking a rational number 10 upon 3. Now divide this by 10 by 3. 3 3s are 9. 1 as a remainder. Put a point 0. 3 3s are 9. 1 0. 3 3s are 9. And this will be repeat. So this becomes 3.333 and so on, and you can write it 3.3 bar, which is repeating decimal, and you can convert it in decimal form. We will learn how to write, and we will convert it in p upon q form. This is the p upon q form of the repeating decimal. So this is a true statement. Now last one, 0 is a rational number. 7th part. 0 is a rational number. You can write 0 upon 1. This is a rational number. So this is true. So our all parts we have find by true or false. This session will be complete. Now we will continue the question number 3 in our next video. Okay, you please like, share and subscribe my video. Thank you, and wait for next video.